So this screencast is just going to be a review of our first order kinetics homework. That way you know if you are on the right track as far as kinetics goes. And this is a little different in our approach in the sense that since we had only discussed first order reactions, you knew going into this that all three of these problems that were assigned were going to follow first order kinetics. When we add on second order and zero order, you'll actually have to test by making the three different graphs to see what order it is. But for now, you know going into it that these are all going to be first order. So on 27, they give you, let's see, concentration of H2O2 versus time. So they have time here, and they have the concentration of H2O2. So again, since we know that this is first order, we know that it'll follow the integrated rate law for first order kinetics. And so negative KT plus the natural log of H2O2. So in the problem, they want us to solve for the concentration of H2O2 after 4,000 seconds. And if you look at your table, it goes up to 3,600 seconds. And so they're asking for a value beyond that point. So you've got a couple of options. If you want to do like the full tilt sort of, full kinetics thing, you would make another column in your table with a natural log of hydrogen peroxide. And then you would graph on the y-axis the natural log of H2O2 and time on the x-axis. You would get a line, and from that line you would take the absolute value of the slope, and that would be equal to your K. So you could put that into Excel, you could do it in your calculator, however you wanted to do it in order to get that K. Now, you also have this integrated rate law, since we know that it's first order. And we only know that, again, because it has to be first order, because that's all we've done so far. So you could certainly pick two data points. Easy one would be time equals 0, and any other, and plug in that time, plug in what the concentration is and what the starting concentration is, and solve for K. So when I did it, I got a K of 8.3 times 10 to the negative fourth inverse seconds. So that was my K. So now that I have that, I can, again, pick any of the data points that I want to in order to solve for the concentration of H2O2. So I've got at T equals 0 that the concentration of H2O2 is 1.00. So if I plug in, I say, well, the natural log of concentration is equal to negative 8.3 times 10 to the negative fourth times 4,000 plus the natural log of 1. And you'll see that that actually works out nicely because this just goes to 0. The natural log of 1 is 0. That's where that graph of natural log crosses the x-axis. All right, so then we end up getting the natural log of hydrogen peroxide. Concentration is equal to 3.3, negative 3.3. And so again, to solve for that, we would say E to both sides, and you get a concentration of 0.037 molar. So that would have been your final answer on 27. All right, on 38, let's see. It is radioactive decay, it looks like. Yep. And it follows first order kinetics. They just straight out tell you. And they want to know how long it would take for 95% of a sample to decay. So we did very similar questions like this in first year chemistry. When we're given percents, we're really given a lot of information, but students stress because they're like, they didn't give me an initial amount, they didn't give me a final amount, but you can assume whatever initial amount you want. So let's say that A naught is equal to 100 grams or something. Then the amount remaining at time t, if 95% of that had decayed, would just be 5 grams, right? And so since you know it's first order, and in the problem they want to know how long does it take, so they're looking for the time that it takes for it to do this, we know it follows first order kinetics. Well, that's great and all, but we need to know what is K. But if you look at the problem, they told you what half-life was. They said the half-life of this is 14.3 days. And so if you remember, the half-life for a first-order reaction is 0.693 over k. So if I now know what t1/2 is, then I can certainly solve for k. And when we do that, that k comes out to 0.0485 1 over days. So now I've got enough to figure out the time. So again, first order kinetics, the natural log of a is equal to negative kt plus the natural log of a naught. So my a naught is going to be 100. My at is going to be 5. I'm going to plug in my k, and with a little algebra, I get time is equal to 61.8 days. So that was your answer to 38. All right, so hopefully that has helped kind of set you up in reviewing your homework. If we look at 40, it's very similar. They tell you the rate law for the decomposition, and they actually give you the differential rate law there. It's a little different than previous ones. They give you the rate equals the whole negative thing, but then they say k times pH3. And you'll notice that pH3 is to the first power. And so that's your differential rate law, so they're telling you it's second order. So again, you can use the integrated form, plug in your 1 molar for your A naught, your time is 120 seconds, and your AT is 0.250. You solve and get a K of 0.0116 inverse seconds. So K is 0.0116 inverse seconds. And then applying the next problem, you've now got your K and enough information to solve for T, so time comes out to 150 seconds. So those are your 3 first order homework problems. Hopefully that went well. If you struggled, please work with your partner, see if you can figure out maybe where you've gone wrong now that you have the correct answers.